Hey, Luke and Riam. So,
Hi.
Hi.
can you all see? I've got all of you over here on this screen so I can see you, and then you should see the screen I'm presenting, which says Physics 200, Mr. Stapleton. It's got some colorful pictures. You seeing all that? Good.
Yeah.
And also, I'm at the moment I'm streaming this live to YouTube, and the benefit of that is it automatically gets recorded. So if anybody misses this, they can go back and watch there. And let me show you. Got 3 cameras. I don't know. I can show you this one. So here's oh, the one that you're probably seeing me on. Looks like no. The one you're seeing me on is over here. Then I've got this one on my computer, and then I've got this other one right now on a sheet of paper. So, and I dropped an air conditioner on my finger, in case you're wondering what the deal is with my finger. Eventually, this is going to fall off. It's been a couple of months. I would expect it to fall off. Let's see, who else is here? Jack, good to see you. So, and Thomas, I can't remember if you go by Tom or Thomas or Tommy. Which is it?
I go by anything. Tom or Thomas.
Tom or Thomas? Okay. That works well. I've already got a Tommy in another class. Hello, David, Jackson. We've got a lot of people whose names begin with Jack in here. 3 Jacks and a Jackson. So, Cassie, are you related to Emma?
No.
No.
That's a difference like with the last name.
Oh, okay. I should have noticed that. Hi, Jack. Hey, Garrett. So if any of you are curious, you can go to my YouTube channel right now, Mr. Stapleton. If you go to YouTube and type M-I-S-T-E-R, Stapleton. Actually, I can do it. I'll take you all there on my screen. I'm streaming this, so none of you will be there, but here's what it looks like. We should see it. It'll say live. Yeah, this is it right now. I can open up the live stream, and it's got a lag. It'll say live. Yeah, this is it right now. I can open up the live stream. You can see there's a lag of 30 seconds or so. I'm going to get out of there. That's kind of weird. So if you ever get, if you ever have a bad connection on our meet, you can just go there and look at that. And I guess I can move this out of the way. Just have to move it back when I'm done. So let's do there'll be a warm-up every day. And, oh, hi, Christina. And let's see, who else is that? That must be Margaret. Do you go by Margaret? You're Margaret, right?
Yeah, my name's Margaret, but I go by Sophia, which is my middle name.
Oh, I wouldn't have guessed that one. So,
Yeah.
all right, Sophia. I've got my mouse hooked up to a different computer, and you're on a different screen. So every once in a while, I'll lose my mouse. If I look like I'm lost, it's just my mouse is lost. All right, who else is there? If you want to be called something different, something other than what it says on your screen, we'll sort that out. I know some of you, so I know what you want to be called in the future, or I know what you want to be called now. So this warm up, I'm assuming you can still see it. The first question is, how are the photos on the right created? I don't know if you've ever seen things like that. You've probably seen things like this. Does anybody know how you would take a picture like this? It might be different now with digital cameras and with phones than it was with an old film camera. Anybody? For today, I guess I won't call on people. So the way this works is you get your camera or phone or whatever, and instead of just pointing it and clicking, like take a picture and having it be over with, what happens is the shutter or whatever lets the light into the camera stays open for a while. So in the picture on the top right, with those are cars going down the street, instead of just taking a picture that goes click, click really fast, lets in the light, gives you a distinct picture, the shutter stays open, so all the light that's coming from the cars keeps doing that as the cars are driving down the road. So you get this trail. And some people like
Wait,
to do.
are you
I don't
sharing
think
it?
we can see anything.
You're
Yeah,
not
we
seeing
can't see
anything?
any.
No, I don't think we can see your screen.
Yeah, so there's my first technological failure. I'm sorry. I should have started that right away. So if I start saying kooky things like, and by the way, now you're seeing the colorful screen, right? Like the pictures of the night sky and the city, yes? Okay. If I start saying kooky things like, look at this picture and there's no picture here, then just immediately jump in and correct me, because I do that. All right, so this is what I'm talking about, these pictures on the screen. These are long exposure pictures. One is a city at night with cars moving, and one is the night sky. And if you were in my earth science class, I think I showed you one like this. The night sky picture, those are called star trails. And the way that works is you point a camera at the sky, put it on a tripod, and leave it there. And as the Earth rotates this way, it looks like the stars are rotating the other way, so you get these trails of the stars moving through the sky. So this is an actual picture somebody took by leaving the shutter of a camera open for maybe, I don't know what fraction of a circle that is, but a full circle for all those stars would be 24 hours. So maybe that was an hour-long exposure. Can anybody guess what that is, what that bright thing in the sky is? I'm not going to tell you unless you guess. Maybe, what's that?
Is it the moon?
It is the moon.
The moon.
But why would the moon look like that? Why would it be so bright on the ends? The stars, you can
Because-
see, what's that? Riyam?
Because it's rotating.
It's not because it's rotating. All the stars and the moon, they're all moving across the picture, and the stars don't have bright spots on the end, but the moon does. Do you have any other ideas about why?
Is it because the sun is like behind it?
The
Yeah, it's
sun
like reflecting the.
is definitely the sun is what lights up the moon in the first place. So the sun in this picture would be it's behind the Earth because it's nighttime. You can kind of see a glow on the horizon. I don't know if that's a distant city or something, but it's not that the sun brightened up when the moon was here and then brightened up again when it was down here. The sun didn't change. Something else. I would never have guessed until I looked it up.
Is it the camera focus? Like it was focused at the beginning, and when the shutters closed at the end, it became unfocused
Nope,
and made like a brighter light.
not that. It's a good guess though. And I'm going to show you another picture in a little while that maybe will give you some insight. So again, I'm not going to tell you the answer, or maybe I'll tell you next class. Now the real point of all this, since the first thing we're doing is kinematics. Kinematics is the study of motion without really worrying about why you have motions. So the other class that just finished up term 1 and that you'll be moving along with when term 3 begins, they just finished Newton's laws. And when we get to Newton's laws, we're going to be focusing on forces and how forces cause changes in motion and cause accelerations and things like that. Right now, we're not worried about forces. We're just going to talk about velocity, speed, position, acceleration, that kind of stuff. So this warm-up kind of relates to that. It's a tricky question. There's a bicycle there, and you can see the little yellow circle. That represents a flashlight or an LED or something that somebody has attached to the bike tire. And the question is, what sort of a pattern are you going to get if you took a long exposure picture of this in the darkness? I did this at Burlington High. I've got a picture I'll click on in just a minute and we can see the answer. Actually, you could do that if you went to my website and you click the link right here, but don't do it yet because that spoils it. So the question is, as the bike rolls, or I've got a tire right here, if I put a flashlight right there and I turned off all the lights and we took a picture and it lasted long enough for me to just keep rolling this thing, rolling. I don't have a long enough counter here. But what sort of a pattern would it make? You feel like, what's that?
Is it like a sine wave or something?
Might be. Anybody else have a guess? You could just draw it in the air if you want. I'll show you the answer in a second. Hardly anybody ever gets this right. People get close.
I guess just be like flashes or like circles, like circle lights. I don't know.
Circles of light? Okay,
Yeah, I guess.
I'm going to reveal the answer here and then talk.
Wait, is it a straight line?
No, not a straight line. And I'm seeing some kind of, like the people who look like they're conducting an orchestra. You might have it right, I don't know.
To go up and down,
Goes up and down, but not directly up and down.
kind of like with like a junction.
Here it is. I'm just going to show you. So that's what it looks like. And one of the keys to understanding what's going on here is to look at the thickness of the thickness of the beam as it moves along and how bright it is. You can see the brightest spots are right where the light would have been at the bottom. It's not quite touching the table because when I made this picture, I stuck the flashlight in the spokes right down. Oh, yeah, I guess you can see me. Spokes right down here, so it doesn't quite touch this table. But when it gets closest to the table, it's really bright. And at the top, it's really thin. So in fact, the higher the flashlight gets, the thinner the beam gets on this. So does anybody have any insight into why? Why does the beam get thinner at the top?
The angle of the light hitting the camera.
Not the angle.
The amount of light the camera sees at a certain point.
Sort of yes and no. I mean, that would be when I reveal the answer, I think you could argue that you're kind of right, but it's more complicated than that. The amount of light given out by the flashlight is the same the whole time.
The speed the flashlight's moving?
Exactly. Where's it moving the fastest?
At the top.
At the top. So that's why it gets thinner, because the flashlight spends a long time at its lowest point, and then it accelerates, and it gets fastest at the top, and then it gets slower and slower again at the bottom. So as I roll this tire along, like this, what's the fastest part of the tire? I'll roll it back and forth and back and forth. The fastest part would be where? You might say, oh, the whole tire is moving together, so it's got to be the same speed. But no. Now, relative to the Earth, one part of this tire is moving faster than the rest. What's an answer?
The top?
The top, yes. So I don't know who that was, but what's your reasoning? Why is the top going faster than the rest? I guess the picture shows it, but.
Well, I feel like I don't know how to explain it, but the bottom of the tire would be touching it, like, I don't know how to explain it.
It's a hard one to explain, and there are a couple of ways that I'll try to go at it. So here's the most straightforward way I can think of to explain this. If you have a tire, I'm just going to make up a speed, and let's say that, draw a few spokes so it looks totally realistic. And the tire is moving this way, it's rolling this way at 2 meters per second. So that's the speed, or we can make it 2 miles per hour or whatever. That means overall, like if this were attached to a bicycle, the bicycle would be going 2 meters per second. Now, if you lifted the tire off the ground while it was doing that, and you just held it in place, then every point on the tire would be rotating around like this, and every little point would be going 2 meters per second, 2 meters per second, 2 meters per second, around and around. So that would be the tangential velocity of a point on the surface of that tire. But there are a couple of things happening. We'll talk about translational motion, and then rotational motion. So the overall velocity of this tire going this way is 2 meters per second, but the top of it is rotating this way, and the bottom of it's rotating that way. And since every point on the tire is going 2 meters per second, 2 meters per second, 2 meters per second, 2 meters per second, the point on the top of the tire is not only moving to the left along with the rest of the tire, but it's also rotating in that direction. So the entire tire is going left 2 meters per second. The top of it has this additional rotational speed, 2 meters per second to the left. The bottom of it's rotating to our right at 2 meters per second. So if you're right here and you're rotating rightward at 2 meters per second, but you're on a thing that's going leftward at 2 meters per second, what's your total velocity? This would be like standing on a train or a cart or something like that, and the cart's going 2 meters per second to the left, but at the same time you're running 2 meters per second to the right.
So the velocity would be 0.
0, exactly. So now if this person turned around and ran to the left at 2 meters per second, how fast would he or she be going?
4 meters per
4.
second.
So being at the top of the tire is like being on a car running the same direction that the car is going. Being on the bottom of the tire is like being on a moving car running in the opposite direction. So they cancel out. And that's probably the simplest way to explain it. So we're going to be talking about speed and velocity. These are mostly velocities here. And the important thing about velocity is it has direction. So you can end up adding together a couple of velocities that are both positive, and then you get 0. You can also add together velocities that are in the same direction, and then you get something bigger than you started out with. So I'm not going to belabor that too much more, but I didn't mean to zoom in, but do go back to the picture. When we get into friction and we're talking about cars stopping, this is going to come up again. This is really confusing to people, but I'll just give you a preview of this, because bad weather is coming up pretty soon. If you're driving along in your car and you want to stop as fast as possible, is it better to skid like this, or is it better to stop as fast as you can without skidding? What do you want to do, skid or not skid? Not skid. And the reason is friction is stronger when you have two surfaces that touch one another and are not sliding across one another. Once you start to slide, friction becomes weaker. We call it static friction between things that aren't moving relative to one another, and then kinetic friction where things slide. So with a car, as long as you don't skid, the tire and the ground are not moving at all relative to one another. The tire and the ground are just totally the same speed. Neither one is moving at all. Once you start to skid, then the tire scrapes across the ground and the tire is actually moving as fast as the rest of the car. Okay, enough of that. I'm going to get you ready to do the homework, because what I really don't want to do is talk to you too long today. So I'm going to do a demonstration that I failed miserably to do during the first term, and I think I've got the technological know-how to make it work this time. So on my screen here, all this stuff where it says important things you need to know, I'm going to skip over that. Class logistics, blah, blah, blah. Motion matching interactive activity. That's you have an assignment tonight, and the assignment is to answer these questions I'm about to show you. So some of you picked up this packet. If you didn't pick up this packet, if you go to Google Classroom, there's a digital version of this where you can find it. And on page 6 of this, there are these motion matching questions. So on a motion sensor graph of position versus time, which I'm about to show you, what does a positive upward slope tell you about motion? What does a negative slope tell you about motion? So this is your assignment. If you want to, I made a video that's also in Google Classroom where it's me explaining all this. I don't mind if you watch the video and you get the answers from there, but that's the assignment. So, going to try not to show got my two screens close together. What I don't want to do is have all of you in my video. This is the graphing, motion matching thingamabob. And that's me. And this, oops, okay, I've got to figure out where my mouse went. So the screen that you can see right now, there are just so many of me. What you might want to do on your, in Meet is unpin me so you've got a bigger view of what's over here, because that's what I'm sharing with you is going to be the most important part. So when I click collect, there's this motion sensor right here that is measuring the distance between me and the motion sensor. And because I picked it up like I did, it gave me funny kind of data. Let me do that again. Collect some more. So right now, I don't know if you can see the units very well. I'm holding it a little bit less than half a meter away from myself. Now the goal of motion matching, usually this would be done by you, but since the pandemic is what it is, I'm going to be doing it, and I want you to suggest how I should make this work. So when I click collect, it's going to create a graph showing my position over time, and what I'm trying to do is follow that line there. So I'm going to pick somebody randomly and have you tell me what to do. See, I can't see all your names right now. I'll just do Jack, because Jack's Sinnott, one of the 3 Jacks. So Jack Sinnott, what should I do if I want to match that thing? Like how far away should I be in the beginning, and what should I do first?
You should be a little further than you were originally.
Like this far? Well, you can't see the distance. So 0.7 meters. All right, maybe somewhere around here. And what am I going to do? What's that?
Yeah, it says 0.7, right?
Okay, so in the beginning, when it's flat, what do I do? Do I start moving? Do I move toward it, away from it, or do I do something different? What's your guess?
Wait, what?
What do I do first?
Move away from it.
All right, so I'll just do that first, and we'll see what happens. Okay, so, all right, so let's modify that. What should I do instead of just moving away from it? Still Jack, what do you think?
You should keep it solid in front of you for a few seconds.
So
it doesn't go out.
Do I move toward it or away, or do I stay still?
Oh.
It's measuring the distance between the two of us. So that red line is just a measure.
You stay still.
Stay still. Okay. And then when I get to the part where it goes up, what do I do then?
Go back.
And then when I get to the flat part at the very top, what do I do?
Stay still.
And then when it starts to go back down, what do I do?
Go forward.
Go forward. Now, do I go forward faster or slower than I went away? What do you think?
Slower.
Nice. Well done. I'll try to do it. Ah, dang. Sorry, my screen's a long way away, so I went too far back. But that was basically it. So nice job, Jack. I put you on the spot there. I'm going to go to a new one and pick somebody different. So that was position match 1. Here's position match 2. All right, so this is what I want to do this time. Let's see, who can I pick from over here? I'll do the next Jack, Jack Cannizzaro, in the blurry shadows. So Jack Cannizzaro, what do you think? How far away should I stand in the beginning? What's that? Jack?
Closer than you are, or what do you mean?
Like how far away? Just tell me. How many meters?
0.5 meters.
0.5 meters. All right, I think I'm about 0.5 meters. And then what am I going to need to do to make that position versus time curve?
Sorry, sorry, I got interrupted. What's up?
That's okay. So how should I walk away, or should I walk away, or should I walk toward it? And what sort of speed should I do?
Walk away and at a slow increasing speed.
Slowly increasing speed? All right, here goes. Ooh. I want to try that again. I think I started going too fast. All right, so that was it. I was walking away at a slowly increasing speed. And because it's kind of awkward to call on people, there's a word for increasing speed, and that word is acceleration. So this is showing I'm accelerating, speed is increasing, and if you look at the position's growing. It's getting bigger positively. So we would call this positive velocity, and we'd also call it positive acceleration. Let me go to the next one, then I've got some more questions for people. Position match 3. No. All right. Let's see. Who's the next? I'll pick somebody from the bottom down there. Abby Robbins. So, what am I going to do here? Tell me how far away I should be in the beginning first, and then tell me what to do.
Is that 0.7?
Yeah. So 0.7 meters. And then what do I do?
And then stay still until it gets to like where it starts to go up, and then move back really slowly, and then stay still again.
Okay. Now, when I move back slowly, should I move back at a constant speed, or should I be changing speed as I move back?
Change, like when you start after you're done staying still, like change your speed.
Okay. So here goes. I'm going to do it slightly wrong, and then tell me what I did wrong.
Okay.
So first I went too far back, but second, there's something about the way I changed my speed. And when I went from still to moving backward, when I was moving backward, what should I have done differently? Abby again.
You should have.
That's okay. Yeah, Abby.
Me?
Yes.
Like you should move back slower.
Slower in the beginning, but then toward the end, a little faster. So you can see it's kind of got this curve to it. And one thing I've been not saying yet is I haven't been talking about the slope. So if you measure the slope of this at any point, what does that tell you? Like, raise your hand if you want to answer it. I'll call on you. Anybody? What does the slope tell you? Okay. Oh, okay. So, Claire, what's the slope tell you?
Well, the slope of the red line, it was steady, and there was no increase in the slope until you started moving back. But when you started moving back, you were increasing at a steady rate, so it was more of a line.
Mm-hmm.
Whereas the what you were trying to do, or like the graph you're trying to meet, you would be increasing your speed slowly as you move back to get the curve.
Right. And then the broader question is the slope itself. In the beginning, the slope is 0. At the end, the slope is 0. And then in the middle, the slope starts to get a little bit steeper. It grows. You know, the slope is 0, then it's got a little bit of a positive slope, then a bigger positive slope, then a bigger positive slope, and then none again. So if I just calculated slope and got a number, what would that tell me? If I calculated it 2 different places, Senate. Velocity, exactly. And so you could say speed or velocity, it really tells you both. Right now we have an upward slope, which means I've got speed away from the sensor, At some point here, we're going to have a downward slope, which means I have negative velocity. So slope is velocity, and or slope is speed. And acceleration is change in velocity. So if you see the slope changing when you've got a curvy line, that means we've got some acceleration. Straight lines mean constant speed. All right, so let's move to the next one. I'll pick somebody else. All right, so Sophia, what would I need to do here? First, how far away should I start out? And then tell me what I would do one step after another.
So it looks like you're starting at like 2 meters. So
Somewhere around
first
here.
what you want to do is you want to stay still for the first part until it starts to decline.
Right?
And then like you want to go forwards like kind of fast, and you want it to be like at the same rate. And then once you get to the bottom where it levels out, you want to just stay still.
Okay.
And then you want to move back again at the same rate the whole time, like the same speed. And then once you get to that part where it levels out, you can just stay still.
Now, if you look at those two slopes, there's the first downward slope where I'm going back towards this, and then there's the second upward slope. Which of those, Sophia, which of those do you think is steeper? First one or the second one?
You're going to be moving faster the second one because it's like, I don't know, like it's steeper.
It's
and it
steeper,
looks
yeah.
like it is.
So in the first downward one, I'm going to have a kind of medium negative velocity, which means my position is decreasing. And then in that second slope, I'm going to have a faster positive velocity, which means my position is increasing. I'm adding on position faster than I took it away in the beginning. So everything you said was right. I'll try it. Ooh, this is pretty good so far. I didn't go fast enough back, and then I always go too far in the end. But everything you said was right. All right, let me see. Do maybe one more. And then I need to wrap things up because I don't want to keep you too long. I don't know if your other teachers have told you, but the administration has told us unless we're teaching an AP class, we need to not go over 45 minutes on these days. So if your teachers are doing that, find a nice way to remind them they're not supposed to do that. I guess I'll do this. So let me pick somebody else. Christina, what should I do? Just tell me like the whole
Okay,
thing.
so you're gonna start 2 meters away,
Okay.
and then you're going to move backwards at like a constant rate, and then you're gonna stay still with that,
Okay.
and then you're gonna move forwards also at a constant rate, probably a little bit faster than you move backwards,
Yep.
and then stay still again.
Yep. Sounds good. All right. I've been counting floor tiles. Floor tiles are about a foot, so 3 of those should be about a meter. And so, all right. So I need to be going back right at the beginning. And let's see. Probably get some more information. I need to go back about 2/3 of a meter, and I need to do that in 1 second. All right, here goes. I can't even see it. I'm so far away, I'm just guessing. Wasn't a terrible guess, I guess. Oh, I went off the screen. Yeah, I went way too far back. All right. I think that's enough of that to give you an idea of what's going on. So I'm going to. I want to use my mouse again on my main computer. So I can have some better control. Go back to my website and just tell you a little bit about the class, and I've only got 12 minutes. So it took me a long time this last quarter to figure out that I needed another screen to keep everybody on, because in the beginning I was just hiding everybody since I'm streaming all this and recording all of it. I don't know that I'm going to record classes this quarter. It's kind of a hassle. And since I already have the other ones recorded, I could just point out parts of those old videos. If you missed the meet, you could still go get the notes and see stuff from those. So I can move that out of the way. Now, one thing I'll do every once in a while is I have this little window. Just if I'm recording on YouTube, which I'm doing right now, they can't see everything you're seeing. They don't have the Google Meet view. They just see my screen and nothing else. So I do this because sometimes I gesture and I need to show what's going on. So the first thing, let me go to Google Classroom. My website is my gateway for everything. It's how I keep organized. And on my website now, if you click Physics or if you click Physics 200 T2, that'll go to your page that I just was on. And if I click this Google Classroom link, that takes us to Google Classroom. And go to classwork. You have two assignments right now. One is the Google Meet, which I just put there so that you know that we're going to have a Google Meet. And after this is done, I'll take a link to this recording from YouTube and I'll put it in here for anybody who missed it. But I don't care if you turn it in, you don't need to turn it in. I'm never going to give you a grade for this. It's just there to let you know that's what we're doing today. This assignment, the motion matching questions, here's a link to the handout. If you don't have it, you just go to page 6 in here. I guess I could go to page 6. I think that's at the end. And these are the questions. So answer those questions. And if you struggle on those and you want some help, I've have this video that you can watch. It's me answering all the questions. But otherwise, when I assign homework, I just expect you to do it. And then if you have any questions, we'll talk about it tomorrow in class. Super important for you to do enough of the homework so that you understand whether you understand it. And I had a lot of people who were not doing the homework this year. They weren't asking questions. And we were doing these Google Meets where I couldn't see anybody. Their cameras were off. And I just assumed they were understanding everything and they just didn't have any questions. And then we got to the test and it was bad. So it's your responsibility if I'm teaching something and you don't understand to ask about it in class. Really take that seriously. I don't give you busy work, at least not intentionally. Everything I give you, it's practice for the tests. So that takes care of your obligations for this next class. Still got a few minutes. Let me show you this is the course syllabus. It's on my website. I don't think I put it in Google Classroom last time. Some basic information about what we're doing. Part 1, you can see, trying to zoom in here. Kinematics in 1 and 2 dimensions, that's what we're starting now. And then we'll get to forces and Newton's laws in 1D. It looks like we're not doing much in the first term, but there's a lot in that. Those are big units. Those set the build the base for everything else we do. Part 2 is going to be the rest of mechanics, which is things that are not related to optics or electricity. I'm going to skip a little bit and tell you about my grading, because my grading is kind of weird. Those of you who were in my earth science class, I think this is the way I did it in there, but it's a little bit different. So I'm just paraphrasing here, but up to 20% of the grade in this class will be based on the completion of practice. So homework and stuff like that. When you do a homework, you just mark it complete in Google Classroom. And I'm going to check every time we have a test. I'll put your test grade in and I'll go and I'll look and see how many of those assignments you marked complete. And then I'll put them in PowerSchool. And if you do all of those, that's an easy 20%. So you get all of that 20%, you get 100% of it. And then your tests are going to count for the other 80%, which is way more. Now, if you don't do any of that homework, then your tests are going to count 100%, and your homework doesn't count at all. So you don't get zeros, it just means it doesn't count. But that doesn't mean you shouldn't do it because it's there because it's helpful. And I just give you full credit for trying on it. So if you do half of the homework assignments, then your tests are going to be 90% of your grade, and the homework is going to be 10%. Any questions about that? If you have questions later, just come back. Yeah.
So is it a bonus? Or if you do it, it's helpful for the test?
Oh yeah, yeah. So the reason for all the homework assignments is that there are things you need to learn and you need to practice, and if you don't do them, then you're probably not going to do well on the test anyway. So the homework is super important, but if you feel like you're busy and you don't get one done on time, and I don't want to give you a 0 for it, or if you totally understand something and you feel like I don't need to practice this, and you're right, I don't want to force you to do it because for you that would be just extra unnecessary work. So it's not really a bonus, but it's easy points. But it's not a whole lot of the points. Most of the class is tests. Really comes down to whether you understand physics or not. And regarding the tests, I'll give you at least one retake for every test. And some students, when we get to the test, they think they know it, but it turns out it's very different having a real test than it is studying on your own and testing yourself and doing homework. And some of you are good at simulating what the test is going to be like and preparing, but to a lot of people, they think they know it until they take the test. But then I want to give you another chance, and you'll have another chance. So we'll have 3 tests this term, and if you want to retake any parts of those tests, I'll usually break them into pages or sections. So there might be 3 to 5 sections. So you're falling asleep. This is good to know that you're falling asleep. If I don't have pictures, I can't tell you're falling asleep out there. What was I saying? I was saying that you can take sections of the test, like there's usually maybe a multiple choice section, a short answer section, a problem section. If you did well on the problems but not on the other 2, you can just take the other 2. And you get to keep all the points. It's not like test corrections where you correct it and you get half the points back. Some teachers do that. I feel like if you know it, then you should get points for it, get all the points for it. Any questions?
Where can we find the link to your website? I couldn't find it on Google Classroom.
Yeah, I should put that in Google Classroom. Just right now, open up another window, and I'll show you how to get there. Just type Mr. Stapleton, mrstapleton.com. I've had this domain name since I left my middle school teaching job in 2005. And that was back before Facebook or anything. I thought this would be a good way to keep in touch with my old students, but I've just used it for organizing my classes ever since then. If you want to see what we did last quarter, you go to my website and you just go down to right here, Physics 200 2021 Term 1. If you click that link, then this is what we did yesterday. And if you scroll down all the way to the beginning, this is what we did the first day. We didn't really do all that the first day. I had sort of high expectations for myself, and it was a train wreck. So I've learned a lot about how to teach to people who are not here. Any other questions before I set you free to work on those questions? Anything else that's on my... What's that?
How will remote, Derek?
Just like any other day, pretty much. Just we'll have a Google Meet at the beginning of class, which I had a study hall in here during the. Sorry, it's bothering me. I want to get back to this class's website. So I had a study hall 3rd block, which I don't have anymore, and I didn't really like it, but it was nice because I could set up in here. This quarter, I'm going to have to come in and set up, so we probably won't really start with the meet until class is supposed to start at 1:20. No, 1:25. What time does class start? Does it end at 1? Does it start at 1:20? 1:25. The meet probably won't get going until 1:30. But every day there'll be a good portion of class where I'll do a warm-up and I'll be teaching something something new, and that's to everybody. So everybody show up for that every day, whether you're here or at home. And I'll try not to keep it too long, and then you go off and do whatever you need to do. And if you can't make it, on Google Classroom, I'll have a link to a video. It'll either be from class that day, or it'll be a video